So today our topic is polymers. So polymers is the is a generally material we can see in every day of our life. Okay. So in this video you will be learning about polymers and types of polymerization and examples of polymers and what are the types you have to prepare it and what are the applications of polymers. Okay. So just go with first. We starting about introduction of polymers and we learn to polymerization, types of polymerization, degree of polymerization, and functionality. So after the discussion in the next video, we will discuss about plastics, how to prepare the plastics, and what are the molding techniques, what are the methods. We will take it briefly. So today we will go through about what is the methods, what are the introduction to polymers. Okay, so in our daily life we see different types of polymers, like from the morning wake up from the brush teeth to by going to the bed in everywhere without plastic we can't imagine our life, like without polymer also, right? Rubbers as a polymers, and we see the most of the daily life the best examples of polymers is plastic. Rubbers are plays very important role. As an engineer you have to know about how to molding, how to make this plastic material and what is these things. Okay, so let us start about introduction of polymers. So polymers are macromolecules formed by linking together of a large number of small molecules called monomers. The polymers are giant molecules with high molecular masses. For example, the monomer take ethylene. Ethylene is linked with many other ethylenes molecules to form a polythene. This large number of like vinyl chloride molecules combines to form polyvinyl chloride. Like we see, if you see in your houses, the wires construction PVC pipe. If you see plug wire, the plug wire is connected with the copper wire is coated with the plastic, that is PVC, right? So, for example, what is a monomer? How we can identify a monomer? So the monomer is a single repeating unit is called a monomer. A resultant higher molecular weight compound is also called as a polymer. So I ask a question: all organic molecules are act as a polymer, are formed polymer. All organic molecules are act as a monomer. This is the question. So this question we'll going to answer in this video. Okay, so let us take about what are the known examples which are called as a monomers, right? See, ethylene, which double bond, this breaking with form a chain. What is said as a monomer, right? The single repeating unit is called a monomer, and the resultant high molecular weight. That means what I said. The monomer ethylene gets linked with many other ethylene molecules to form a polythene. Like one molecule is going to combine by another molecules, right? We can see this reaction here, right? This bond is going to right. This bond is going to break, right? So then there is a vacancy here, carbon, right? Another carbon is added. Like similarly, another ethene will come, right? Another ethene will come. C double bond C. Again, this bond is broken. Like similarly, one is going to added, and is one is going to added, right? One is going to added. Like this is going to continue. Okay, so this is a what how the polythene is going to form. Okay, so we see in the previous example, this is a part. This is a part which is a repeating unit, right? This is what a repeating unit in a polymer. This repeating unit is called a monomer, right? So what is meant by poly means many, the many repeating units to form a polymer, right? If you see polythene, this is a repeating unit. If you see polyvinyl chloride, this is a repeating unit. If you see polypropylene, this is a repeating unit. The repeating unit in a which form very large chain molecules, it's a large molecule chain like structure. This is called a polymer, and these are called a monomers, right? So here this ethylene is a monomer. Here the vinyl chloride is a monomer. Here propylene is a monomer. Okay, for understanding this monomers concept, you don't want to learning about more organic chemistry. You just know about carbon's number. If one carbon 2 is there, that is ethylene. 3 propylene. 4 um, 4 is but, and 5 is penta. Like this, if you know this number, you will do wonders of it, right? So if you don't worry about why I'm writing the reaction or not, just understand, if you see this reaction, break this bond and write like n, that is enough for the reactions, right? If you're practicing these reactions, there's nothing more about it. Okay, so this is what you understand about, hope you understand about poly and mer. Okay, so what is a macromolecules? So why these macromolecules become polymers? On the basis of the physical property, these polymers with a high degree polymerization is called high polymers, which is called a macromolecule. That means the monomer which are formed to 5,000 to 2 lakhs approximately. These are called macromolecules. Those macromolecules are polymers, right? So the number of monomers in a polymer is called a degree of polymerization. This degree of polymerization, what is meant by the number of monomers? Here we write n. Here we write n. This n is nothing but degree of polymerization. So that means the number of molecules which are going to form a polymer. What are the number of molecules? N. The total number of single monomer units combined together form a polymer is known as a degree of polymerization. That means the degree of polymerization is depending on the number of molecules which are forming a macromolecule. So these macromolecules are called as a polymers. Okay, so let us see an example. Right, polymers, as I said, a Greek example, like which is a built-up link with a large number of small molecules. Those small molecules are called as monomer. Right, if you see what I see the previous example, this is called a mer, PE polymer. Okay, this is general definition. We can write our definition as example. In examination, you have to write that. Without writing example, there is no use of theory. So write in the definition of polymer. At least explain with one example. Hope you understand this example. Right? Just breaking the bond. See here, two number of carbons are forming a chain-like structure. Okay. So what is meant by monomer? It just said small molecules which combine with each other from a polymer molecules is called a monomer, which is a repeating unit. Right? I say let's take example styrene. Even the benzene is there. The benzene is not involving in the polymerization. See, while you're writing the reaction, just write first carbons right? Write down the carbons. And what is the valency of carbon? 4. So first write down the bonds. And here the benzene is repeating two carbons. At రెండు carbons repeat అవుతున్నాయి. Here this is a 1, 2. First write down these carbons and fill it with hydrogens. This is how you write up with a what do you call writing the reaction. Okay, so here for example, polythene is for polymers and monomer writing. So in examination, writing about polymers means you write about both polymer and monomer, right? Sorry, don't ask about monomer means, no, you have to write about polymer and monomer, both you have to write. Okay, here these two are reacting sites, right? So here you. So let us discuss about polymerization, the fundamental chemical process by which the low molecular weight molecules are converted into high molecular weight with the elimination of small molecules like water, ammonia, alcohol, etc. Without such elimination is called a polymerization. Generally in the last we see the polymer formation or monomer formation. Simply you tell about polymerization is nothing but the formation of a polymer. Simply the synthesis of a polymer in the lab, or the synthesis of the reaction is called a polymerization. Okay, so this is a chemical process. Okay, so as you said, here I've again discussed about degree of polymerization here, because polymerization discussed after the degree. So the polymer chain which is requiring the in the polymerization, what is the number of reactions, number of monomers involved in the polymerization is called degree of polymerization. Degree of polymerization is must be 5,000, 2,000 somewhere raising. Here what we're writing about n is called a degree of polymerization. Okay, so you have one question when the question the monomer, right? The essential requirement of a small molecule should be at least two reactive sites. So in the previous class, the previous starting of the class, I asked about all organic molecules are monomer. No, some molecules which have at least two reactive sites. Two reactive sites means at least double bond or triple bond, or functional groups like OH, right? So you can ask an example. Take alcohol C2H5OH takes C2H4, which is act as a monomer. Sir, functional group OH is there, why can't it will be monomer? Right? So if C2H5OH is there, if we add two C2H5 molecule, then C2H5O, that means reaction will stops. But if you take ethene C2H4, it form polythene, right? Even the function group is there, the function group must be forming a, like take ethylene glycol CH2OH single bond CH2OH. Here two OH will be there. These two OH will form continue the chain. This ethylene glycol reacting with terephthalic acid form a terline, right? So that means at least the monomer, the minimum qualification for monomer is bifunctional. Minimum qualification. For example, if you came to BTech by writing an MCET examination, what is the minimum qualification? Intermediate, right? You have to you must pass intermediate. Like similarly, the minimum qualification for a monomer to form a polymer is called a it must be two reactive set minimum bi. If one bond is there, there is no chance of. Why can't you ask CH4? Why methane, ethane are not? Why double single bond are not forming? If single bond is there, there is no chance of continuation. If double bond is there, this is going to break and forming a chain, right? That is called a functionality. The number of reacting sites for a monomer is called a functionality, right? If the functionality is 2, that is like see here the functionality is 2, vinyl chloride CH2 double bond, this is double bond. Ethylene glycol functionality is 2, minimum is 2, right? Must be greater than equal to 2, there is no 1. Here C CH C6H5OH 3 triple bond will there. So that is functionality is 3. CH2OH formaldehyde, its functionality is 2 because formaldehyde HCOH, right? So here see this is adipic acid, so two functional group is there, so that's why functionality is 2. Ethylene functionality is 2, right? So these all bifunctional which have a 2 is called a bifunctional, right? If it is 3, it is called trifunctional, greater than 3 polyfunctional. If bifunctionality is there, the structure is linear. Trifunctionality is that the structure is branched. If polyfunctional is the structure. So the functionality, what is the use of functionality? By knowing the functionality, bi or tri or poly, we will know the structure. Okay. So now we will discuss about very important after the types of polymerization. So there is 3 types of polymerization: addition, condensation, and copolymerization. Okay, so let us talk about addition, right? The word chain indicates, right? Addition is nothing but it's called a chain polymerization. The word like how it chain is going to elongation, like similarly the word chain indicates the carbon skeleton from a polymer. The double bond breaks and resulting two single bonds either side each carbon, which is going to form a chain, right? So addition polymerization is undergo monomers have a C double bond C, C triple bond C, like ethylene, vinyl chloride. I shown in the previous vinyl chloride and ethylene. These are forming a addition polymerization. The structure of addition is like said, it's elongation of chain carbon chain. That is a linear structure. The rate of reaction is also very high. See, this is an example I shown. Ethylene has 2 carbon atoms and 4 hydrogen atoms, and the polyethylene is a repeating structure. So there is no chance of losing any molecule. So that means the polymer have a multiplication of 2. That means how many carbons will be there? The number of carbons in the polymer is 2 into n. That means there is no chance of removing hydrogen. Similarly, 4 hydrogens will be there. In the polymers also there is must be 4 into n. That there is no chance of leaving hydrogens. So addition is a chain polymerization, which is a chain structure, and in this polymerization there is no chance of removing any molecule. Okay, so these are some examples like polythene, ethylene, and you know about hydrogens. You know about these things like these are some examples. These are uses. This will use in case of plastics. Okay, these are all are plastics. Okay, these are some more examples. Okay, so let us see about condensation, right? The monomers which have a functional groups here. So there is no functional groups in the addition polymerization, but functional groups. But removing small molecules of HCl like salt, alcohol. Unlike chain polymerization, there is not an exact multiple number. Here there is a exact multiple number. But here due to loss of molecule there is no exact multiple number. right? So let us see the example. The best example is nylon 66 bakelite and terylene, right? Bakelite is in the chapter we know about bakelite type preparation and properties also. See, this is called aminocapric acid. That this is a polyamide. See, in this molecule, water molecule is removed. So this water molecule is removed. That's the reason the condensation polymerization. Nylon 66 is also example. See, this is what I want to show about nylon 66. Right, hexamethylene diamine. So meth means how many number carbons? 2. Methylene, right? That means 2 n's. Amine means NH2, right? This is adipic acid, 4 carbons. See, right, by condensation the water molecule is removed, right? Minus H2O. So that means water molecule is removed, but this is going to form by this is called nylon 66. What is the exact difference between the chain and condensation? That means addition. This is called step growth polymerization. That is chain growth polymerization. Right here, due to the water molecule is removed, the structure is chain, and here the structure is branched or network polymer. Okay, right. This is next one is copolymerization. Copolymerization is it is between the addition and condensation. See here, double bonds is going to form, but there is no chance that will different monomers here, right? See, in the addition polymerization, same monomers, all are same. There is no two different monomers are not involved. Same monomers are involved in the reaction. But see in the condensation, right? Condensation, two different monomers or function groups are occurred. So that is the exact difference between the here. Here two different monomers, but there is no byproduct, right? That is called copolymerization. See, this is 1,3-butadiene and acrylonitrile, which is called butadiene, is example for copolymerization. And another example is styrene rubber, styrene and 1,3-butadiene. This is guanise. Guanise and guanine example for copolymerization, and these two are the synthesis. What I call for synthetic rubber. Okay, so let us see very important concept about addition and condensation difference. As I told you, this is chain growth and the step growth. As I told you, the polymer takes place by addition of monomers, but this is stepwise condensation. This is a multiple bonds having monomers, but this is a reactive functional groups. Like here, double bonds like triple bonds is going to form, right? That means like double bond means alkanes and alkenes. Here there is no elimination. Here there is elimination. Molecular weight is formed by soon, but molecular weight increases steadily throughout the reaction. This thermoplastics are formed by this reaction. Thermosettings and thermoplastics sometimes. Reaction must be required a catalyst, but reaction must be by heating, right? Because by heating the reaction is going to form. The reaction proceed fast, comparatively slow, right? And this is a polyethylene, polystyrene, polypropylene, as examples, and bakelite, ureoformal resin as examples. Hope, right? This is the first part of the polymers and plastics unit 3. The next chapter we will learning about plastics and how the plastics are molded, how the plastics are compounding is going to form, and we will learning about how to manufacture the plastics also. At last, we will learning about how to manufacture bakelite and polyvinyl chloride, what are the properties and what are the applications, right? Hope you understand the class. Be safe and be home. Thank you.